All right, let's look at this problem called top k frequent elements. Let's have a read. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, so here we can see 1 occurs 3, 2 occurs 2 times, 3 occurs 1 times. We're looking for the two most frequently occurring elements. Obviously, it will be first one and then two, and so on and so forth, right? So how can I solve for this? What's the first thing that comes to my mind? Well, obviously the first thing that comes to mind is I have to count the frequency of each and every element, right? So the input example that's given to us is you have one, 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 two, two, three. Well, in this case it's sorted, but it might also be shuffled, right? It could be one, two, two, one, three, one, anything, right? We can't assume that it will be sorted because that's not something that has been mentioned. But ultimately, what we do is we get the num and count, right? We can build this thing. So we'll have, okay, one occurs three times, two occurs two times, and three occurs one times. And now what do we do? So now we want to know that which guy has the most frequency. So essentially now I want to, in some form of fashion, sort based on the maximum frequency, right? I want the guy with the maximum frequency. I could potentially use a priority queue for that, right? So I could use a priority queue where I'll insert each and every element into the priority queue, and the priority queue would be based on the max. It will be max priority queue based on frequency, right? And so it's in this case, I'll first add one into the priority queue, and then when I'll add two into the priority queue, obviously two has lesser frequency, so it goes down. Three has even lesser frequency, it goes down. And then from this, I'll just return the, I'll just dequeue k times from the priority queue, right? And so what is the time complexity of this algorithm? Well, obviously first we get the this map, and so this to do that will be a time complexity of O of n and a space complexity of O of n. And then while I'm adding each and every element into the priority queue, now obviously there were some duplicates. So let's say n star is the number of unique elements, right? So each unique element gets added into the priority queue, and adding into the priority queue, each unique element will be n log n. So that will be n star log n star, right? And building the priority queue obviously was O of n. So we take that, and this is sorry, this is the building this map. This is the creating the priority queue. Now, from this priority queue, we'll take the top k elements out, and removing an element while just pulling get peeking to the top element is fine. But when you're removing it, it will again be like k elements we are removing, and removing an element from the removing min from the priority, removing first element from the priority queue. It will need adjusting in the priority queue, and that adjusting will be log n star. So this is the overall time complexity of the approach, and the space complexity is of n. So let's quickly write code based on this logic. So we go to code and we say, all right, first you want to build the map. So let's have a map from integer to integer. Let's call it count map, right? Equals to new int, sorry, new hash map, and we go through the nums array. So for each num in nums, we're gonna ensure it is in this count map. So count map dot put num. If it's already present, we'll increment its count. So we'll do map dot get or default of num 0. Like this will add or increase its frequency. Now I have the unique elements and their counts into the array. And now I want to build a priority queue. So a priority queue uh, of integer equals to new priority queue. So A and B, what will it return? It will return this count map dot cat of B minus count map dot get A, right? So based on the frequency, I'm adding it to the priority queue. And so let's add each element to the priority queue. So for each num in the count map, so for each num in count map, I'm going to add it into the priority queue, and then the top k elements I'll remove. So I need a result array which will be of size k. This is what I have to return, and in this I'll add the top elements with the highest frequency, right? Top k frequently occurring elements. So which would be just essentially k dqs from the priority queue. So for int I equals to 0, I is less than k, I plus plus, I do result of I equals to priority queue dot. Right, and that's the logic. Let's run and see if it works or not. It gets accepted for the initial test cases. Let's submit and see if it works for everything. And it does seem to work. All right, now if we go back to the question and if you look at this follow-up, it says your algorithm's time complexity must be better than n log n. So while our solution did get accepted, however, as we discussed earlier, if we go back to the time complexity of our solution, we did see it is around because of this using of this priority queue, it is sort of n log n-ish, right? So how can we improve and make it better? So what we did was we built this for every num we got this count. Now, one of the question is, and then essentially what we're trying to do really is we have this counts array sort of, right? And here we have count is 3, count is 2, count is 1, and we know, hey, 3 corresponds to this, and 2 corresponds to this, and 1 corresponds to this. So this is count, and this is the nums, right? And what we're really doing is just sorting this array, and the sorting of this array is taking sort of if n this n star log n star time, right? That's essentially what's happening. So the question is, the array was of size 6, and the counts array, the n star is 3, right? But we're looking at this n, and we want to ensure that the overall time complexity is less than this O of n. Then a question to ask is what is the maximum value of count? And when we ask this question, we'll get the result that count is bounded by n, right? Because count is actually the number of occurrences, frequency, and the worst case would be same number occurs multiple times, right? 1, 1, 1, 1, 1, 1. In that case, count of 1 will be 6, and max count value would be 6. So what we had was, hey, on an array of size 6, we had three different counts, 1, 2, and 3, and we are sorting it, right? Instead of that, why not we say, hey, in an array of size 6, we can maximum, the counts can range from 1 to 6, right? So why not find all the numbers corresponding to each and every count? So here we can see, well, from this nums to count mapping, we can see that a num1 occurs 3 times. So at count 3, I have 1. Okay, let me know this. I have 1. And for count, sorry, for count 2, I have 2, right? And for count 3, sorry, for count 1, I have 3. There is no number with count 4, no number with count 5, no number with count 6. And then I can just go through this count array from largest count to the smallest count. So this does not yield us anything. This does not yield anything. This does not yield anything. This gives me one guy. This gives me one guy. And we were returning top two. So one and two is what we return. If it's not clear, let's take another example. So maybe this example that we had 1, 1, 1, 2, 2, 3, 3, 3, and let's say some random 4, 4. So let's say this is the input array, right? So the input array size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n equals to 11. So first thing that we build is the frequency of each and every element. 1, 2, 3, 4. These are the 4 elements. This is num and this is count. And we get, okay, 1 occurs 3 times, 2 occurs 2 times, 3 occurs 3 times, and 4 occurs 3 times. And let's say k equals to 2. So we are finding the top two most frequently occurring elements. So now what we could potentially do is okay, so the counts are 2, 3, and 3. 2, 3, 3, and 3. And so we sorted by descending order. So 3, 3. That's what essentially the priority queue was doing, right? 3, 3, 2, and 2. And this 3 corresponded to this 4, this 3 corresponded to this 3. So this, sorry, 3, 3, 3, and 2, right? So we would return 4, 3, 1, and 2, something like that. Like, so 4 is the longest, 3, 4, 3, and 2 have the same. So any one of these two can be returned. But we could also do something like, okay, so these are the 4 different counts. Now, instead of sorting or adding to the priority queue, we know n equals to 11. That means the max count could have been 11, right? So now we'll solve for each and every count. So 1, 2, 3, 4, or rather, let's take it in a descending order because we are looking for the maximum count. So maximum count can be 11, then 10, then 9, then 8, then 7, 6, 5, 4, 3, 2, 1. In fact, for more optimization, we can actually keep track of the maximum count. So here we know the max count is 3, right? So we don't even need to build this big. We can only build this 3, 2, 1, and 0. And then we can go through each and every guy. So for 1, its count is 3. So in 3, I have 1. For 2, its count is 2. So for 2, I have 2. For 3, its count is 3. So in count 3, I also have 3. So this was count to nums, right? So like we had the num to count mapping, we create count to nums, a reverse mapping. And looking at 4, it had count as 3, so 4 also comes here. This is our mapping, and we go from the maximum count to the lowest count, and we pick up k elements where k is 2. So first we'll pick 1, then we'll pick 3, and then we'll say, hey, I'm done, right? So that's the logic. Let's convert this logic into code as well. And obviously this, because essentially what we did was, hey, instead of sorting based on the count, we know that the count is limited. So let's go through each and every count and make it linear in that sense. All right, let's coming back to the code. Let's remove the bit that we don't need. So we don't have the priority queue bit. So I remove the priority queue. I remove the priority queue. I have this num to count map. Now let's create this array. So clearly we saw there can be a list of integers corresponding to every count. So we'll take a list of integer array and we'll call it you can call it buckets, right? So for count this is a bucket. For count this is a bucket. So buckets equals to, you know, just array of size, the maximum count, where the maximum count is nums.length. In fact, like we discussed, we can actually figure out the maximum count by uh, here. Let's do int max count equals to 0, and we can do max count equals to math dot max of max count comma count map dot get num. And so, yes, we say that your count is the max value of count can be size or length, but the practical one is actual one is this. So we can actually change this to this max count, right? And now from 0 to this max count, we'll build all. Yeah, count 0 is of no use. So just for the understanding purpose, we'll do it plus 1 and we'll have it from 0 to max count. All right, that will be easy for us to sort of handle. Now we go through each and every num. So for each int num in the count map, what are we gonna do? So we get the value of it, and corresponding to this value. So if buckets of this value is equals to null, then we create this new list. So we create this list. Now once the, and or if, so now if this is created or this was already created, then we will add this guy into that bucket, right? And at the end, what I'm gonna do is now I'll go through this one, and we're not really interested in count. So I is greater than equals to, we could do 1, right? I plus plus, sorry, I minus minus. So count equals to the max count till the count equals to the min count, which we could also maintain a min, but okay, this is fine because anyways we will find the top k before reaching to the min. So we do this, and now let's also maintain like an index into the result array, which we can call j, and we want this j to be less than k, right? Now what we're gonna do is we're gonna add these elements into the result array. So firstly, if in any case, if the buckets of I is null, then we'll just continue. And if that's not the case, then we'll go, let's define some other variable. ijk is used. Let's define p equals to 0, p is less than buckets of I dot size, as well as let's also ensure this bit around j less than k, and we go through p plus plus, and we're gonna do result of j. We will add buckets. So buckets of I dot get p, right? We keep adding elements till we get the top k elements, and that is it. All right, let's run code and see if it works. We get some error. Let's try and fix it. Cannot find symbol buckets dot size. Okay, the buckets is length. So I mean buckets is an array. So we do like this, and let's run again. Okay, these two gets accepted. Let's submit. And it works as well. All right.